In algebra, one of the most important things you learn about is an algebraic expression. An algebraic expression is a mathematical combination of numbers and letters, usually something like this. When students first see an algebraic expression, their reaction is usually something like this. But then they learn that an algebraic expression is just a recipe for a calculation, and then they feel more like this. In this algebraic expression, there are four terms: 3x squared, negative 7x, 2xy, and negative 4. Have you ever wondered what a term is? Well, today is your lucky day. We're going to talk all about terms, like terms, and see why these are all pretty important. Words are powerful things. When you first learn a word, you start with a simple definition, but over time you see deeper meanings. The math word term is just like this. So today we're going to start with a simple definition. A term is a number times some variables raised to various powers. 2x cubed is a term. The number is 2, the variable part is x cubed, and they're multiplied together. 5y squared is another term. The number is 5, the variable is y, it's raised to the second power, and everything is multiplied together. Negative 7x cubed z is a term with two variables. Here, the exponent of z is 1. When the exponent is 1, you don't write it. 3 plus x squared is not a term. That's because we're adding the number and the variable parts. This is an algebraic expression, but it's not a term. However, this expression is a sum of two terms. 3 is a term and x squared is a term. Notice how I snuck in a new layer to the word term. 3 is a term even though it's not multiplied by any variables. So we should probably update our definition. A term is either a number times some variables raised to various powers, or just a number. Like terms are separate terms, which are alike in a very specific way. Their variables and their exponents are the same. For example, 3x squared and 5x squared are like terms. The variable part of both terms is the same, x squared. They have the same variable and the same exponents. When you have like terms, you can add them together into a single term. 3x squared plus 5x squared equals 8x squared. To add these like terms, we just added the numbers. But why does this make sense? Try not to memorize this rule, but instead understand it. Remember, multiplication is just repeated addition. So 3x squared is the same as x squared plus x squared plus x squared. And 5x squared is the same as x squared plus x squared plus x squared plus x squared plus x squared. So if you combine 3x squareds with 5x squareds, you get 8x squareds. This is why 3x squared plus 5x squared equals 8x squared. Even though we don't know what x is, we can still add these like terms together. You can also subtract like terms. What is 5x squared minus 3x squared? Put yourself into a math trance and think about what this is saying. It says you start with 5x squareds and then take away 3x squareds. This leaves you with 2x squareds. So you just subtract the numbers to combine these two like terms. Now look at the two terms 8x and 3x squared. Are these like terms? No. They both have the variable x, but they are raised to different powers. Their exponents are different. Can you add these terms together? Yes, you can, but you just get 8x plus 3x squared. The deeper question is, can you simplify this expression? Can you combine these two terms? No. No, you cannot. Because these are not like terms, our earlier reasoning does not work. We have 8x's and 3x squareds, but since x is a variable, x and x squared are as different as apples and oranges. For practice, let's play like terms or not. I'll show you two terms at a time, and you have to decide if they're like terms or not. 3x to the fourth and negative 2x to the fourth. Like terms, the variables and their exponents are the same. 1.4y and 1.4y squared. Don't let the numbers fool you. These are not like terms. The variables are the same, but their exponents are different. 2mc² and 3c²m. They are like terms. This one's a bit tricky. The numbers and variables are all multiplied together, and the variables and the exponents are the same. Just because the variables are in a different order doesn't matter. mc² equals c²m. 9 and 9x. Not like terms. The first term does not have a variable, but the second term does. Next, I'm going to show you an algebraic expression, and you have to decide how you can simplify it. That is, can you combine the terms together? 8x³ plus 9x³. Yes, these are like terms, and their sum is 17x³. 2x² plus 3x² plus 4x². All three of these terms are like terms, so if you add them together, you get 9x². 9y plus 2x. This expression cannot be simplified because 9y and 2x are not like terms. 3y² plus 4z plus z. In this expression, 4z and z are like terms. If you combine them, you get 3y² plus 5z. We cannot combine these last two terms because they're not like terms. Negative 2xy³ minus 4xy³. These are two like terms, so we can combine them. By combining the numbers, you get negative 6xy³. Combining like terms is an important skill in algebra and in life. You'll use this often when solving equations and inequalities. It's also important when adding and subtracting polynomials. You'll see this again in many future lessons.